So yesterday actually, last class actually solved this part actually up to this one. So let's start with that topics.
Sir, your screen is not shared.
I'm not sharing the screen.
No, sir.
Okay. Can you see it right now?
Yes.
Yes,
Yes,
yes.
sir.
All right, that's great. Okay, let's continue with that part actually. I'll discuss that problem solving actually initially, then I'll move to that last topic, which is center mass of this chapter. Let's say this is a block. It is stationary, this block. The mass is m. Let's say this is that the velocity of this block is 0. You fire with your gun towards that bullet. It's a wooden block, think about. And the mass of the bullet is given, which is, let's say this is that, I should write, and this is the mass of the block, this is the mass of the bullet, and it moves towards that block with a speed 150 meter per second. This is actually that before the case. And what happened after the impact, this bullet is embedded inside that block, which means it is inside the block, and it makes a collision. Actually, after the collision, these two systems moves added together with a common velocity, which is the p, and after traveling a distance, this total system completely halt over here, which means that final velocity of the total system is 0. Now this, they give us some information. The mass of that block is 2 kg, mass of the bullet is 5 gram, and speed is given, which is that velocity of bullet is 150 meter per second. Initial velocity of the block is given, which is stationary, that's why it's a 0, and the distance is travel, which is 270 centimeter. Now they ask you find out frictional force acting between that block and that surface over here. Now this block actually make a collision. What type of collision it would be? Can anyone tell me? When the bullet impact with that block, after the impact they stick together. The bullet is inside the block actually, which means it makes a completely inelastic collision, right? Remember I said you, after that collision, if the two system has a common velocity, then the system is, that collision is known as a completely inelastic collision. Due to that, maximum amount of energy will be the loss. We said in that one in the previous class. So right now, this system, bullet and the block, travel to 70 centimeter. I mean, after traveling, it becomes stop over there, right? It stopped because of this frictional force. If you draw that free body diagram of this object, you will find out this should be actually that weight, that should be that mass of the bullet plus mass of the block, right, into the g, that should be your normal reaction force, and that should be your frictional force. This is simply the free body diagram of this system. So we need to find out this frictional force over here. Now to find out that frictional force, I'm going to use the idea actually over here. The formula I'm going to use over here, I'll write down. So net work done should be simply the change of kinetic energy, right? So net work done means work done by this gravitational force, work done by this normal reaction force, and work done by this frictional force. I know that work done by this uh, normal force and the gravitational force would be 0, right? Because they make the angle 90 degree with the displacement. Displacement is towards that direction. So that's why if you write down, so work done by the normal reaction force, work done by the gravitational force, plus work done by the frictional force, that must be change of kinetic energy means kinetic energy final minus kinetic energy initial. Final kinetic energy is 0 because it stop over there. Work done by this
Sir,
normal
what
reaction.
is that?
Which one?
What is work done by acceleration?
Which one? Acceleration means?
What is that one? Just below W external.
This is not external. This is the net work done.
Sorry, net. What is below net W
N.
work done by the?
This is N.
Oh,
Wn, work done by the
sorry,
normal
ma'am.
reaction force. This is Wg, work done by the gravitational force. And this is work done by the frictional force. And work done by the gravitational force is also the 0, right? Why it is 0? Because they makes the angle 90 degree with the displacement. So that's why you will find out simply work done would be over here by the frictional force, and that must be would be initial kinetic energy of the system, because that amount of energy is going to be lost from the system totally. So work done by the frictional force, you can write down work done by the force into displacement, and the angle is cos of 180 degree minus ki, and then I can also drop this minus sign because this is cos 180 degree is also the minus 1. Then I will find out Fkd would be simply kinetic energy initial. Now you can find out this Fk, that Fk would be kinetic energy initial. You can write down that should be a half of mvi square divided by d, right? This is the formula. Now I know this is the mass of the total system. Remember, this is the, I write down the mass. I can write one more line. It should be that mass of the block plus mass of that bullet into vi square, which is the total velocity, and 2d. This is my formula. I know the mass of the bullet, mass of the block. I also know the d. Now I have to find out that vi. Now what is the vi over here?
So where to find that out?
Sir, after the collision, the
VB plus VB.
No. This is the velocity is over here. This is, I'm saying that this is the initial
so
velocity.
combined velocity after collision, sir.
Yes, exactly. Which is that velocity after the impact actually, right? So I didn't use that I index because when that's mean I need to write down that momentum conservation over here. So again, this is actually that comprehensive problem I'm doing over here, because this is the one, that part I'm solving for using that work energy theorem. Right now, to find out the velocity, I need to apply the momentum conservation actually, right? Since it's a completely inelastic collision, I'll write down that whether it's elastic or inelastic collision, momentum will be conserved, right? Then I'll write Pi must be equal to Pf. Remember, this Pvi is supposed to be not that initial velocity of that before the impact. This is the initial velocity after the impact actually, right? Or you can simply write down the v instead of write down vi. You can simply write down the v. Then it will be actually, you can overcome that confusion. So it's supposed to be v square, and this will be also that v square. Let's write down that part. Then pi.
Can you go a bit above?
Why? I said I'll give you that hand up.
I don't feel like copying later on.
You need to understand right now why you're writing. If you write, if your concentration is towards that writing or copy that one, then you are not going to get the point from here. It's not going to be beneficial for you, I think. All right, is that okay? Should I move?
1 second.
You are killing my time.
Done.
Yeah, speed up, increase your acceleration. All right, so initial momentum, that must be momentum for bullet, which I am supposed to write mb vv plus mvvv, that must be mb plus mvv into v, right? Now this is 0 because block is initially rest. Then we can find out this, oh god, who is knocking me right now? So divided by mb plus mb, that's with the velocity. Now you can find out and plug it into over there. So because we have that numerical value, right? So I'm going to put into that over here. So if you put that part, you will find out this velocity is going to, because let's plug in those values. So 2, oh no, so no mass of that, that's the mass of actually bullet, which is not the 2 kg, it is actually the 5 gram. So into 5 into 10 to the power minus 3, I need to convert to the SI system into that velocity, which was 150 divided by 2 plus 5 into 10 to the minus 3. That will give you 0.37 meter per second. That's the velocity after the impact, both bullet and the block. Due to that velocity, it will travel that distance, which is actually 270 centimeter. Now if you plug in those value over here, you will get that this frictional force acting on that, because that would be 2 plus 5 into 10 to the minus 3. This is that mass, the combined mass, into the velocity actually 0.37 square divided by 270 centimeter, which actually 2 into 2.7 meter. If you plug in, then you will find out this Fk should be 0.05 Newton. That's the frictional force is acting on that.
স্যার এই ভেলোসিটিটা তো মেইনলি যখন বুলেটটা ব্লককে আঘাত করে ওই সময়ের ভেলোসিটি না?
Right after the impact.
এটা মানে মানে যখন আঘাত করে এর ফলে ভেলোসিটিতে কি হয় সেটা?
Exactly. All right. So this is the frictional force. Now, if I ask you what is that coefficient of kinetic friction between the block and that inclines or the surface, then you can find out, right? So we know that this frictional force would be mu k into the n. You can find out, you know, the frictional force. You can find out the normal reaction force on there, and you will be also able to find out what should be the coefficient of kinetic friction between the block and the surface. All right.
স্যার একটু উপরে নেওয়া যাবে?
Obviously, why not?
স্যার আর একটু উপরে স্যার, কোশ্চেনের পার্টটা।
You will get this video, even though it is already in my YouTube, because I did the same thing in every semester.
ডান স্যার।
Done? Okay, that's great. still sleeping mood? Are you guys in the sleeping mood?
No, sir.
No,
No,
sir.
sir.
Yes, sir.
Who are still in the bed right now?
Me.
Yeah. Get up from the bed.
স্যার বেডের উপর স্যার একটা টেবিল রাখছি ওটার উপর বসে পড়তেছি।
You're in the cheering mood. All right, let's think about it. This is very interesting. Should I any curvature path over here? No. Uh-oh. It's going to be tough. This would be smooth, although my drawing is not exact, but think about it. This is a smooth curvature path over here. I keep two block, one block actually over here, and I release another block over here. So this is, they give us some information. The height of this, it is actually on a tabletop. This is a table. This height is given. This height is 90 centimeter, and this height is 30 centimeter. This is that block is M, and this is another block. It should be smaller actually. We should draw a smaller block. So this is just disturbing in this online class. Okay. That's why I do not like this online. It's a frictionless path, remember, this is totally frictionless. This is the only information given over here, that this smaller mass actually half of this capital mass. What will happen over here if you release this bigger mass M? Is going to be that make a collision, right? After the collision, what will happen?
So the block with small m will get a velocity and fall from the ground.
Okay, there could be one possibility. What about the bigger mass?
Sir, both the object will fall from the tabletop.
Sir, it will maybe the bigger mass can be fall from the surface, or it can be stopped.
It can be stuff, yeah. Yeah, that's a wild guess, I should say actually. Yeah, unless the after that impact, the velocities of both block is negative, then it will move towards the forward direction, right? By any chance, if the velocity after the impact become negative, then they will bounce back in the opposite direction, right? So that will depend actually, depending on that velocity after the impact actually. All right, so we'll see actually what will be the case actually. So unless you are not certain that the velocity is going to be the positive, then you cannot say that these two block is going to fly from this table, right? If you find out the velocities of these two block is positive after the impact, then it will be fly off from that surface. And if it is fly off, then where will we fly? Let's say it will be fly. Why? Because look at this. This is actually the smaller mass M2, and this is the bigger mass. Obviously, when this bigger mass is going to be strike with that smaller mass, it has a higher momentum with respect to the smaller mass. After the impact, this one will be fly off. Both will be fly off actually. Actually, this, because you will find out that velocity of both two one actually become positive after the impact. So that's why this one will be fly off from the surface. All right. So can you tell me if both two will fly off? So where they will be strike? Will they strike in the same position, or they will be striking in the different position? Hmm?
Different position, sir, because the velocity will not be same.
Then fine. Which one will be covered the larger distance? Hmm?
The one with higher velocity.
One with higher velocity. All right. That's more technical answer. Yeah, obviously you're right. The velocity which one has a greater speed or velocity after the impact, that one is going to cover the larger distance, right?
Yes, sir.
So that could be also done from there actually. All right. So fine. And I'm going to find out actually where they are going to be strike and with what velocity they are going to strike over there. That's my target actually from this question. Unless I do not reverse the situation, then both two block is going to fly from the surface because we need to find out that velocity is over here. All right, to find out that velocity, I'm going to use the equation I give you. Remember, V1F, which I write M1 plus M2 V1I plus M1 plus M2 V2I, and this one should be M1 minus M2, this should be 2M2, right? This one's the equation I'm writing you again for you. So this is V2F should be 2M1 divided by M1 plus M2 V1I plus M2 minus M1 divided by M1 plus M2 into V2I. This was the equation, right? Now I'll consider this one would be my first object, capital mass, and this one would be my second object. This V2I actually that 0 because it is stationary before the impact, right? Right?
Yes, sir. Yes, sir.
What about the V1I?
So will it have a velocity of gravity?
Yeah. Does any of you have that intention that V1I is also going to be the 0?
I think so.
Yeah.
Yes,
Yeah.
I also.
Yeah, that's I'm not
Yes, sir.
saying.
At top, the velocity is zero, sir.
Yeah, that's very good. That's natural. Obviously, you can think about that. The V1I is also going to the 0, but that's would be the wrong over here because if V1I is also 0, then the situation is not going to change. V1F and the V2F would be also the 0, right? Which means the system will be completely static. The event is not going to happen, right? If you think about the V1I is also the 0, then this system would be look like freeze over here. Whatever it has, it will be totally the static. It will be look like a picture.
Yes.
Yeah, that's not going to happen in the reality, right? Because once you release the bigger mass, this one will be slide down and it will be strike that block. That would be the velocity. V1I would be just before the impact. It was over here initially, that's 0, but when it's calmed down, before the impact, it has some velocity. That is actually the V1I. Remember I said that momentum will become just before and just right after the impact. That's why the velocity will be also there just before the impact and just right after the impact into that momentum equation. That's why, although it has that initial velocity 0, I release from the rest, but that's not the V1I for the momentum conservation equation. Because it has that potential energy, that's going to be the convert to the kinetic energy. We are looking for that one. That is the V1I over here. Now V2I is 0, that's fine. This would be 0, this would be also the 0 in that case. My calculation is going to be that less cumbersome over here. So now I need to find out that V1I. V1I I can find out directly. It should be that energy conservation law, right? Its potential energy is going to be that convert to the kinetic energy. Then I will write down simply, because it's a frictionless, that's why I'm writing EI equal to that EF, or is this subscription is a confusing would be over here. I'm not going to write down that one. I'll write down directly the equation. So I have that MGH must be equal to that, or you can write if you understand that part. It's not a big deal. It should be half of m v1I square. Can you write this one? Do you understand? Because it has that potential energy, whatever it has, that must be going to convert to the kinetic energy over here. That's why I write down that part.
স্যার কার্ভের ওইটাতে কি কোনো ফ্রিকশন আছে?
No, it's a frictionless.
আর যদি স্যার এখানে ফ্রিকশন থাকতো তাহলে তো স্যার ইকুয়েশনটা তো ভিন্ন হতো।
Exactly. So that should be that change of mechanical energy should be work done by the frictional force or non-conservative force, right? Remember, this one I write down del E actually the 0 for conservative system, and for non-conservative system del E equal to work done by the non-conservative force. All right, then I can find out this B1I should be this should be also bigger mass. I'm sorry. And remember, this value of this bigger mass is actually not given into that question. So because it is redundant, actually, it doesn't require over here. It will be useless. Mass will be cancelled out from that part actually. That's why we don't require that masses over here. So then you can find out this m will be cancelled out. I'll find out this V1I would be simply root over twice GH. I know the G, which is 9.8. I know the H. H is 30 centimeter. This is the 30 centimeter. Then it will be, if you plug in those values, you will find out this V is going to be the 2.42 meter per second. That's the initial velocity of the block just before the impact. Now, if you plug in those part over here, what will happen? I'm going to plug in over here this. I'm going to write this part over here because otherwise it cannot be solved. This V1F should be, I drop the second part because that's 0. My M1 actually the bigger mass, and this is the smaller mass, M plus M, V1I. This will be my equation, right? Then look at this. I can plug in because the smaller mass is given, which is m by 2, right? M plus m by 2 into V1I. I know everything over here because right now you can factor out this m. It should be 1 minus half divided by, it should be 1 plus half into V1I. This will be cancelled out m. You see, I say that this is going to be 11 actually. Is going to be that half, and this is going to be that 3 by 2 into V1I. Actually, you find out 2.42. Then you will find out this V1F is going to be that 0.808 meter per second, which is positive. That's important for me, which means this one is going to be that fly off from the surface at that velocity, which is 0.808 meter per second. Who is knocking me right now? Sanjani. Alright, so this is that velocity for V1F. Now what is the V2F? V2F would be same, it should be that 2m1. 2m1 means bigger mass divided by m plus bigger mass by 2, which is smaller m, into V1I. That you can write down, it should be 2 divided by 3 by 2 into 2.42 is the multiplication. Then you will find out this V2F is 3.23 meter per second. That's also positive. That's I'm saying that both two block will be the fly up from the surface. If I get V2 F is 0, then it will be stop. If I get the V2 is minus sign, then it will be bounce back, right? Now I can say that both two block is going to fly off from the surface. Which
স্যার
one will
তাহলে তো
be?
ভি টু বেশি ডিস্টেন্স কভার করবে কারণ ভেলোসিটি বেশি।
That's great. Now I can ask one more question over here. So which one going to take the longer time to strike the ground? Or which block will be strike the ground first? Or are they going to strike the ground at the same time?
Smaller M is gonna be the first one.
Smaller going to strike the ground first? Why did you think so?
Because the velocity is higher.
Smaller one is not higher. Smaller one is 0.808. Smaller mass. Oh no, yes, smaller mass has a greater speed, right? Which is, yeah, this is actually small
Yeah.
m. Yeah, you were right. This is for the smaller m, and this is for bigger m. This is a bigger m object, which means, yeah, what is your point? The smaller one is going to strike the ground first.
As the velocity is higher and it's gonna take less time.
Is there any other opinion?
স্যার এটা উল্টা হওয়ার কথা না, ওর যেহেতু ভেলোসিটি বেশি ও হরিজন্টাল ডিস্টেন্স বেশি কভার করবে, আর বেশি কভার করতে বেশি টাইম লাগবে।
Okay, all right, there is a counter logic. Borno, can you give your explanation, or can you justify your answer, or is there any other opinion from any of you?
স্যার এই ভেলোসিটিটা কি তখনই হবে যখন কিনা এটা ডেস্টিনেশনে পৌঁছাবে?
No, this is the velocity just
Like
right after the impact.
মানে স্ট্রাইক করার পরে যে ভেলোসিটিটা তৈরি হয় সেটা?
No, this is the velocity just, yeah, after the impact over here, not at the ground part. This is the velocity just right the collision moment, after the collision
হ্যাঁ
over
যখন
here.
যখন সংঘর্ষ হয়েছে তার সাথে ফলে যে বেগ তৈরি হয়।
Yes, exactly, this is the velocity. Now, is there any other opinion? The flight of time, these two blocks are the same or they are different? Borno said it would be different. A smaller one will be strike fast, and another guy said that no, the bigger one will be strike the fast because probably he's thinking it has a bigger mass. Huh? Is there any other opinion?
স্যার এখন তো স্যার ভরবেগের তুলনা করলে কি আমরা জানতে পারবো যে কোনটা আগে পড়বে আর কোনটা পরে?
Momentum, no, that's not the relation of that part actually. Yeah, Abdullah, can you say that one? No one can say that one.
Sir, I was trying to solve with equations.
We're trying to solve that equation. What about Nevas? Nevas, are we over here?
Sir,
স্যার V2 হবে স্যার।
sir, the higher velocity, the one with higher velocity will strike the ground first.
Yes.
Yeah, that is the point of the Borno, right, Borno?
Yes.
স্যার আমারও সেম পয়েন্ট।
But
Because it is moving faster than the first block.
All right, so no one is going to defer that part. But that's wrong actually. Because they actually that strike the ground at the same time. Flight of time will be the same over here.
Yes, sir. The equation says so, sir.
Yeah, oh,
Because, sir,
exactly.
d naught y is 0, sir.
Exactly,
For
because
both of case.
yeah, the reason is they are traveling the same vertical displacement, 90 centimeter. Those are the velocity actually towards the horizontal direction. It's not, if there is any velocity towards that vertically downward, then it will be strike the first, because both has a initial velocity towards the y direction is 0, right?
Yes, sir.
and they are also traveling the same distance in the vertical direction. Obviously, they will take the same amount of time. Those are the velocity you find out over here. This is the velocity towards the horizontal direction. It's not towards the vertical downward direction. That's why these two blocks will be strike at the same time, at the different position with the different velocity, but they will strike the ground at the same time, which means the time of flight would be the same. Did you get my point?
But sir,
No, sir.
Yes, sir. Yes, sir.
Yeah,
different, yeah, I'm trying to say, যদি different velocity তে different পজিশনে এরা নিচে পড়ে তাহলে x কিভাবে সেম হয়?
Yeah, that's a very good question. Different velocity
Sir.
means, yeah, I'm coming to that. Different velocity means I say that when they strike over here, I said at what velocity? Look at this. Once it's come off at the point over here, its velocity is only towards the horizontal direction, right? Which is the Vx. That's the Vx you find out, and it will be remain same throughout its journey. Once it fall, initially the vertical component is 0, but right now gradually it's going to be the increase this part. The Vy is going to be the increase, right?
Yes.
So Vy would be the same because they start from the same over here. Because remember, we are neglecting the air friction over here. If you include the air friction, then it will be a little bit different. Obviously, we are neglecting the air friction.
I didn't get it still.
You didn't still get it. All right, so I'm going to explain. Remember, this is the velocity we are going to find out is the total velocity, right? Total velocity V should be Vx I head plus Vy j head. Am I right?
Yes.
So Vx is, you find out those actually that Vx for these two block.
Yes.
Now I have to find out the Vy. Vx is different, although Vy is same, then the total velocity would be different. Did you get that one right now?
Yes, the velocity would be different.
Now fine. Now your point is, now what is your question? Why did you get that one?
আমার কোশ্চেন ছিল যে যদি ডিফারেন্ট ভেলোসিটি ডিফারেন্ট পজিশনে পড়বে নিচে গ্রাউন্ডে তাহলে x কিভাবে সেম?
X is not same. It will be different location, I say. X is different. X is different. Remember, smaller mass has a greater displacement with respect to the bigger mass.
Yes.
I didn't say that they will be strike at the same place. I say they will be strike at the different place with the different velocity, but at the same moment.
Oh.
Time is same.
Time is same, exactly.
So, sir, why the time is same? Actually, this is the question.
Yeah, that's another part. Again, you need to go back to again that kinematics or the projectile motion.
So is it because both of them are getting pulled down by gravity, so
Yeah.
they have same velocity?
Exactly, you can say in another way. That is also another part explanation. But the accurate answer is they are traveling at the same displacement in the vertical displacement, and they start with the same velocity because initially it doesn't have any vertical velocity, which means they start from the 0, right?
Yes.
Yes, sir.
Towards the
Yes.
vertical direction, and we also neglecting the air friction, which means it is actually the free fall in a vacuum place. That indicate they will be strike at the same time. They will strike the ground at the same moment.
So even if we use like s equal to vt and t's value would be s divided by v, as the v is different, we're gonna get different time.
No, that's the wrong answer. You are saying because you are applying the wrong formula. Why you use the s equal to vd? You said the s equal, which is the formula you said? S equal to vt, right?
Yes.
That's for the horizontal part, not for the vertical part, because in the horizontal direction it moves at a constant velocity, but in the vertical direction, is it moves at a constant velocity?
No, it's increasing.
Yeah, it moves at a constant acceleration. Then you are supposed to use y equal to y naught v naught y plus half of a yt square. This is the formula would be for along to the vertical direction. And along to the horizontal direction, you can write down the v naught xt. Using that formula, we will find out the displacement. But to find out the displacement, I need that time t.
Yes.
All right, I should move to the forward direction. Is that okay?
Yeah.
Yeah, this is very interesting problem, right? I like it too much actually. Even though I'm going to include one more topics after covering that rotational part, because if I, in that case, I will the roll down. I will release a solid sphere, then it will be rolled down over here. It will make more interesting. In that case, it has both type of velocity, translational and the rotational part, which is more interesting.
And
So
our
in that case,
Yes.
Our mind will also roll down.
Yeah,
স্যার
that's one.
আমাদের ফাইনালে আমাদের মার্কস এরকম রোল ডাউন করে চলে যাবে স্যার
Exactly. If you understand that rotational motion, then you can handle those part. Otherwise, I'm expecting that you will be wild off in that rotation. I want that your mind should be also roll, or your mind should be also oscillate, which would be the right answer. All right, let's go forward. So, fine. So this is the velocity actually. I can write the velocity for v naught x for smaller m is this part, which is 3.32 meter per second along the horizontal direction, and v naught x for the bigger m, which is 0.808 meter per second. Now if I want
স্যার
to
এটা 3.32 স্যার
3.2,
আচ্ছা না স্যার ঠিক আছে ভুল
no, 3.23. Still right now you was rotating your mind. Come on, I didn't start the rotational part yet. All right, so then I'm going to find out the time first. So to find out the time, it should be y equal to y naught.
স্যার এই সূত্র দিয়ে তো বোঝা যায় যে স্যার দুইটার সময় একই হিসাব করে দেখলাম স্যার
Obviously.
ভি নট ওয়াই হ্যাঁ ওয়াই নট জিরো ভি নট ওয়াই তো স্যার জিরো তো তখন স্যার দুইটার ক্ষেত্রে হাফ এ বাই টি স্কোয়ারটা কমন থাকে
Yeah, that's true. I said you guys, please
আর ওয়াইটাও সেম
believe. You can do actually, you can make a relation with this equation instead of, you can make this, physics is never actually betray with you. Even though your girlfriend is boyfriend is going to be there, sometime do the betray. But this equation will be never give you the wrong information. Believe me, try to make a good relationship with this equation. It will be relieve you a lot of pain. All right. So I'll write down directly. It should be that minus 0.9. This would be 0. This would be 0. This would be minus 4.9 t square. Then you can find out the t. It would be simply 4.28 second. That's the flight of time for the both to block. Then you can find out. So x for a smaller m, it should be v naught x into t. So v naught x actually for a smaller m was 3.23 into 0.428. That gives me actually 1.382 meter, and for bigger m it should be 0.808 into 0.428. That will give you 0.345 meter, which means the smaller mass will be covered the larger distance and bigger mass will be covered the smaller distance. That makes sense, right? But they will be strike the ground at the same time with the different velocity also. Let's find out that velocity. I'm going to find out the y component first. Y component will be same for all two block. It should be v naught y plus ayt, which is 0 minus 9.8 into what is the time? 4 to 8, right? 0.428, which gives me V is actually minus 4.2 meter per second. This is the velocity y component. Now the total velocity for smaller mass, if I write, it should be the Vxi, Vyj. Vx for the smaller mass was 3.23 I hat minus 4.2 j hat. This is the velocity for a smaller mass, and for the bigger mass it should be oh sorry, that was 0.8. It should be 0.808 I hat minus 4.2 z hat. You understand? Alright, so let's see one more case. Actually, let's say if the collision time is let's say actually that
Sir, can you go a bit up?
no, just wait a little bit later. So let's say that collision moment of this collision between the two block actually that 2 millisecond, then what should be the average force actually acting on that block? Let's say two block, because what happened actually the collision moment, this is my bigger block and this is that smaller block at the collision moment. They are going to provide each one another force actually, right? Which is actually that we are telling about this average force actually. Let's say we are going to find out for bigger mass. What is the average force acting on the bigger mass? Then which formula I am supposed to use? I am going to write actually that, remember we write down that impulse, right? So which is the change of the momentum. From that part we can find out actually that impulse momentum theorem. So I is actually del P, that is actually it should be F average into the del T. I know that this is the del T. Then my average force is going to be simply del P over del T. Now what is the del P? Del P, you know that final momentum minus initial momentum divided by del T. We are doing this calculation for the bigger mass. So what is the bigger mass final velocity? Final velocity was what is the final velocity? Final velocity is 0.8, right? 0.8 actually. So it should be m, you can keep it that way, and this is 0.808. This is the velocity, final velocity, minus the initial velocity was just before the impact, right, which is the V1I. That was actually 2.42 divided by actually that 2 millisecond, 2 into 10 to the minus 3. And look at these, this would be the negative, right? This one would be some negative number actually. So I do not know what is that part actually, because let me do that calculation. It should be something minus actually, 0.808 minus 2.42 divided by 2 into exponential minus 3. Oh god, minus 806 m. M is for the mass of the block, because I do not know the mass. If I know the mass, then I can find out that forces, the average force actually acting on that. And this minus sign actually telling you the force would be in the negative direction. This one actually the force provided by this smaller mass actually at the collision moment. This is the average force. All right.
So can you show me velocity of y?
Sir,
Mm-hmm.
sir, average force
Velocity
to
of y.
negative
Okay, okay, I got it. I'm copying it.
Yeah. Yeah. Who is asking the question? Go ahead. What is your question?
Sir, average force to negative can.
Because this is the force on the block capital M, right? We are calculating the average force on this bigger mass. right?
স্যার তাহলে নেগেটিভ ফোর্স দিয়ে আমরা কি বুঝি?
Negative force means the plus and
স্যার
minus sign.
এভারেজ
Yeah, go ahead.
স্যার এভারেজ ফোর্সটা কি স্যার মানে বড় এম এর উপর প্রয়োগ হচ্ছে এমন কিছু?
Yes, this is the force on bigger m provided by the smaller m. So smaller m
ও দ্যাটস
obviously
ওয়াই ইটস
provide.
মাইনাস।
Yes, exactly. Did you get that? Why this minus, or what is the significance of this minus sign right now?
Sir, because it is applied by smaller m into the bigger m.
Exactly. That's it's a negative.
তাহলে স্যার স্মলার এম এর উপর বিগার এম এর কি পরিমাণ ফোর্স মানে অ্যাপ্লাই হচ্ছে এটা কিভাবে, এটা বের করবো কিভাবে?
Same way, it should be also the equal, but in the opposite direction.
Oh.
Newton's third law. In that case, it will be positive. All right, can I move forward?
So y এর ভ্যালুর ওই স্লাইডটা একটু দেখালে ভালো হয়। y equal to y naught plus v naught 1. Yeah. Okay, thank you. Yes.
স্যার টাইমটা এক হওয়ার স্যার আরেকটা কারণ তো স্যার আমরা নিউটনের একটা সূত্র আছে যে বিনা বাধায় পরন্ত সকল বস্তু একই সময়ে মাটিতে পড়ে।
Exactly. We are also doing the Newton's law. I'm not doing anything my law over here. Is that okay?
Yes, it's all right.
Now tell me, is these topics is hard or it is interesting? Or how are you feeling actually?
Interesting but hard, sir.
Interesting but hard. Yeah.
স্যার পুরো রোটেশনাল।
Rotational means?
Sir, brain rotational.
স্যার সরি টু ইন্টারাপ্ট বাট আমাদের তো মনে হয় নেক্সট 4টা ক্লাসের মধ্যে কুইজও করবে।
Yes. At least 2 quizzes I need to take actually.
স্যার কনসেপ্টটা বুঝতে পারলে স্যার বিষয়টা মজার লাগতেছে।
Yes, that's the point. If you understand, I said at the very beginning of this class, if you understand this topic, then believe me, it is interesting and it is very easy. It is very easy. You need to understand actually that physics, because most of the case actually people try to memorize, and that is useless, totally garbage, and then they feel that those stuff are hard actually, but it is not true. All right, let's move to the forward direction. We need to cover one more. When we are going to meet after that vacation? Officially, we have a class.
Online class.
Online class, one more, right?
Yes, sir.
Can you give one quiz online?
নো স্যার।
Why?
Yes,
So you can take online class but not quiz.
sir. You can take online quiz, no problem.
নো স্যার, নো অনলাইন কুইজ।
Why?
Sir, we can complete the syllabus
Yes,
easily.
sir, you can take online quiz.
স্যার
Online?
অনলাইনে কুইজ নিয়েন না।
Sir, our section please not.
বাট স্যার অনলাইন কুইজ দিলে স্যার আবার একটু কপি করাটা ইজি হবে।
Then you should like that online quizzes.
So we know that
জান্নাতি
you
সবাই
will
স্যার, রমজান সব জান্নাতি হয়ে গেছে স্যার।
extreme
তাহলে-
hard quizzes.
রমজান শেষ হতে আরো 2 দিন বাকি।
All right, fine. Let's move to the forward. So,
স্যার অনলাইন কুইজ নিলে স্যার ঈদের পরে নিয়েন স্যার।
yeah, it should be after the vacation actually.
না স্যার অনলাইন কুইজ নিয়েন না।
Okay, let's decide actually after coming from the vacation actually.
স্যার ওই যে সেকশন 20 তে স্যার অনলাইন কুইজ দিন না তাইলে
জি স্যার আমরা অফলাইন দিতে রাজি আছি।
জি স্যার আমরা অফলাইন দিব।
What about section 2? No one from the section 2?
Sir, নিতে পারেন স্যার।
Sir, did you say 24?
No, no, I said that section 2. Yeah, I'm coming to 24 also. What is my...
Yes, sir.
Where is my CR from different section? Abdullah from section 2. Where is from... what is Nawaz?
নেওয়াজ ঘুমায় স্যার।
Huh? He's in the sleeping mode.
Yes, sir.
And where is... I forgot about her name actually. Jaman, something Jaman, right? She is from section 24 probably.
Yes, sir.
Yeah, Arshia Jaman. I forget about your name. Sorry.
Sir, it's Arisha.
Oh, Arisha. Oh, that's my nephew name actually. Alright, so what about your point? Are you going to give you the online quiz or offline quiz?
No, sir, take the quiz after vacation.
Online or offline?
Sir, offline.
Offline.
অফলাইনই স্যার নেন, অনলাইন দিতে গেলে ঝামেলা আবার আরেকটা।
Offline.
Offline? Everyone is asking for the offline.
তা অনলাইনে দেখা যাবে স্যার কপি করতে যাবো, পরে দেখা যাবে কপি করতে গিয়ে পুরো টাইম শেষ।
I know that in the offline it would be hard for me because I need to check all this script, which is boring actually. The only thing I actually do not like this teaching profession to check the script. So disturbing.
স্যার এইচটিপি দিয়ে চেক করেন স্যার।
স্যার আপনার এসটি আছে?
Yeah, I have, but that cannot be done. Stick and
স্যার তাহলে আমাকে দিন, আমি চেক করে দেবো না স্যার।
স্যার আমাকেও দিন স্যার।
then you need to actually pass the barrier actually. You need to give a actually qualify exam.
স্যার এসটি হওয়ার জন্য কি আলাদা করে এক্সাম দেওয়া লাগবে?
And no, it just required some CGPA and also you need to cover probably the 80 credit. After doing the 80 credit, you will be eligible. And
80 ক্রেডিট, ওকে।
And you also maintain a CGPA. Alright, let's move. Is all of you are from Dhaka or is there anyone who joined from your outside Dhaka?
জি স্যার, অনেকেই আছে আউটসাইড ঢাকা, আমি খুলনার।
Oh, that's a very good.
আমি পাবনার।
Oh, you are where?
চট্টগ্রাম।
Okay. Is that
He also from Chattogram.
Chattogram? Is it fascinating? From different location we are, right? Someone actually the northern side, someone actually the southern side of this country. One thing actually I can remember, one guy is actually the joined from actually Bandarban. That actually in the online COVID situation, that guys every day come. And not only that, there is one more guy is actually joined from, I do not know whether I mentioned you that this guy is actually from in our department. He is from Uganda and he joined in my class. That was my scheduled class actually at 11. I forgot about, but he joined actually that at 4 a.m. in his local time. That is was
Wow.
fascinating actually. This
So
boy
much
actually
dedicated.
at my department, he is math department actually. He is doing the undergrad in the mathematics. His name was also probably Abdullah. All right, let's move forward. All right now we are going to talk about that center of mass. That is very important concept for your collision and also for rotational part, because right now look at this, we are dealing with a small object, but what if you consider a bigger object, momentum case? In that case actually we need to consider that center of mass. We need to, because system try to move throughout the center of mass actually when you dealing with the bigger stuff or bigger mass. Center of mass actually we define of a particle in order to predict that possible motion of a system. Let's say I have a arbitrary shape of object, it has a lot of point mass. Who is right now? Is it Nevas? Oh yeah, Nevas is wake up. Nevas? Some of your friend actually mentioned that you are in sleeping mood. Hello, can you hear me, Nevas? Or still you are in the sleeping mood? Alright, let's stop that. He is probably still sleeping. Alright, I'm considering a arbitrary shape of object. I know there will be a lot of point mass. In that case, if I want to write down my momentum equation, which is actually the linear momentum P equal to mv, I need to consider the one mass, right? Because it has the, even though it could be a different shape of object also. So, uniform distribution of the mass or non-uniform distribution of the mass, it could be a different object. Then we need to consider that that type of object, the mass should be concentrated at a single point that we define actually the center of mass. So, instead of, let's say you have instead of, let's say, cricket bat, that is also not uniform shape actually. It has a different mass in the different region. Or best example actually that baseball bat, right? It look like this one. The more mass is that side instead of that. That's why the system has center of mass is also the different actually. We consider this type of shape of object would be the center of mass play a major role to describe the kinematics of that type of system actually. That's why we need to understand the center of mass. Let us start the center of mass for the point mass distribution. Let's say I have, this is the mass m1 and m2. Then we have the general idea that center of mass of these two objects would be at the midpoint if m1 and m2 are equal, right? Center of mass would be at the midpoint. And some of you actually mentioned that as far as I can recall that you guys, if you ever play the basketball, some of you have a tendency that you are going to rotate the basketball on your finger, forefinger, right? You will see, probably you notice that some guys actually rotating this basketball on his or her finger. Then your finger must be put at the center of mass of this object. And there is a reason. I will come to that point actually, because it's played a major role to describe that motion or the kinematics of the system. So, if the mass is uniform, the center of mass of the system will be at the midpoint. Let's say if you have a uniform distribution of the mass, this is the rod, which is uniform. Uniform means mass is equally distributed throughout that length of this rod. That's called actually uniform distribution of the mass or homogeneous distribution of the mass actually. Then the center of mass of this object will be at the midpoint. But in reality, you will find out some shape of object which has not uniform distribution, even though this rod could be look like that. Right? It's a non-uniform distribution of the mass. Mass is more concentrated with respect to that region. That's why it is non-uniform distribution of the mass. In that case, the center of mass is not going to be at the midpoint. It will be shifted towards that more mass actually. It will be shifted towards that point actually. The more mass, the region, the center of mass will be shifted towards that distribution. Someone is disturbing. Please make you silent. All right, now the question is how we are going to find out center of mass of a system. Shayan, make you silent.
Yes, sir.
You are talking. Please make you silent. All right, so now the question is how we are going to find out the center of mass for both type of object, whether it is a point mass or whether it is a uniform distribution of the mass. Let's first consider for the point mass. I have this mass m1 and this is that m2. They are separated by a distance that d. The distance between these two mass actually that d. Now I will choose, this is required, I need to choose a reference axis over here to find out the center of mass. This is my y axis and let's say this is my x axis. That means these two mass actually on the x axis. I am locating from my origin, let's say consider this is the x1 distance and this is that x2 distance. Now I'm going to find out center of mass of these 2 point mass distribution. The center of mass for the point mass distribution, look at this, I write XCOM. COM stand for center of mass. That's actually COM. I'll write in the short form. So that's why this XCOM for this system, I need to write down M1 into X1. So that's mean I am locating the mass from my origin arbitrary. I'm assuming I'm standing over here. M1 plus M2 into X2 divided by total mass M1 plus M2. Do you understand? This is would be the formula.
Sir, isn't it a mathematical equation?
Yes, it's a mathematical equation, obviously. If you have more than 2 mass, you can write down the general form of this XCOM also. If you have M1 X1 plus M2 X2 plus dot dot, let's say I have nth particle, n number of particle into the system, and their distance is xn divided by total mass, which is M1 plus M2 plus dot dot Mn. This is the general formula, remember. Then we can write down in summation notation. I'll write this would be 1 over m into summation I1 to n into xi mi. That's case actually we define that summation notation. All right, where xi actually I is number of particle 1 2 3, I is in start from actually 1 to up to n number of particle actually. This goes on. M is masses and xi actually that position of that masses, corresponding position, and this capital M actually the total mass, where this capital M should be simply mass of all the particle M1 plus M2 plus Mn. Right? That's the general formula to find out center of mass for
স্যার এম এর উপরে ওই জিনিসটা কি স্যার?
1 over m. Similarly, if it is in the y direction, we can write y com would be also 1 over m summation I1 to n mi yi. This is the y com. If it is 2-dimensional, then you will find out x com and the y com. Center of mass actually is simply a location where all the mass you can concentrate would be over there. You have to find out the coordinate of that mass, average mass distribution actually. The same, we can say also that average distribution of the mass location, arithmetical average. That's why one guy actually said it's a mathematical equation. So if it is the z, if it is 3-dimensional, then I can also write down z com would be 1 over m I1 to n mi zi. That would be that coordinate for that part, right? In terms of vector, we can also write down this center of mass actually. This one also it could be right in term of vector, because it says simply that I say that the coordinate, then it can also could be a displacement vector actually. I can write this ri is a xi I hat plus yi z hat plus zi k hat. This is actually I am writing the 3-dimensional case. Xi actually the x coordinate of the ith particle, yi actually the y coordinate of the ith particle, zi is also the z coordinate for the ith particle. For that's mean for one particle which is the I, it could be 1 2 3 4 number of particle actually. By this analogy, we can write down the r com. Same way, it should be x com I hat, y com z hat plus z com k hat, right? That's why in general the vector form we can write down r form would be also 1 over m I 1 to n. It should be mi ri is a vector. All right, that is actually that general formula for point particle to find out that center of mass. Using that formula we use that part. Let's do example. Let's say I have two mass. This is m1, this is m2. They are separated by a distance, actually let's say that 5 meter. Let's say m1 actually 4 kg and m2 actually the 2 kg we consider. Now I need to find out the center of mass of this system. Can anyone guess what should be the center of mass of this system?
So near 4 kg.
Near 4 kg, closest to the bigger mass, right?
Yes, sir.
Yeah, that makes sense. All right, so now I said I will use my x-com equation over here. Instead of, because my x-com equation is actually x-com, you can write, which is actually 1 over m I 1 to n mi xi. I have two particle, so that's why n would be the 2. So that's mean x-com equation, it should be m1 x1 plus m2 x2 divided by m1 plus m2. This would be my equation for this mass distribution, because I have only two masses over here. Now the question is, what should be x1 and x2? Remember, in that equation I choose x1 from my origin. This was actually that x1 I choose over there, right? And this one actually that x2 if I choose the origin outside of this mass distribution. That's the problem, because I do not know the x1 probability. Instead of choosing the origin over here, I will choose the origin at the location of one mass. Then x1 would be 0 for this one, and x2 would be in that case this one, which is actually the 5 meter is given, right? That's why for this case I'll write my x-com should be m1 actually that 4 kg, 4 into 0 plus m2 actually 2 kg, 2 into 5 divided by total mass actually there's 6, right? So 10 divided by 6 you will find out. So then x-com should be 10 divided by 6, which actually it should be how much?
So 1.67.
1.67. All right, thank you. So it should be 1.67 meter. 1.67 meter means from where? From the location of this m1, right? I choose this is my origin. So 1.6. This is actually 2.5 at the middle point. So 1.67 probably over here. So this should be actually the center of mass. This is actually 1.67 meter, which is closest to the bigger mass, because m1 actually the 4 kg. That's why the center of mass of this object would be over here, right? Is there any question over here?
এখানে আমরা x1 কে লাইক বড় ম্যাসের মানে বোঝা যায় যেটা বড় ম্যাসের কাছে হবে, কিন্তু স্যার মানে ইকুয়েশনালি বুঝতে পারিনি স্যার।
Equation, why you didn't get from the equation? I write down that equation. Did you understand that equation I write over here?
Yes sir, yes sir.
Exactly that equation I write again over here. The same equation I'm writing over here.
ডিসটেন্সটা যে m1 এর কাছাকাছি হবে ওই জিনিসটা স্যার।
Oh, because remember when I'm choosing that general formula, I write down x1 from here to here, right? I choose the origin over here. If I do the same thing for this case, that mass, if I choose that origin over here, then I need to this x1. Do I know that x1?
No sir.
But if I choose the origin over here at the location of m1, then I can know that x1. What will be the x1 for this m1?
0, sir.
0, and the x2 would be from this one, which is the 5.
Okay, sir, understood.
Yeah. Is there any more question? Nevas, are you there?
Yes, sir, I am here, sir.
You're here. You are in the sleeping mood. Some of your friends mentioned that you are sleeping.
No, sir, মানে স্যার আজকে আমি স্যার একটু হসপিটালে গিয়েছিলাম, তো স্যার এটার জন্য স্যার আমার একটু মিটিংটা জয়েন দিতে লেট।
Oh, no, no, it's fine. It's fine. It's fine. All right. So, is there any question on that? Please try to understand. This is a very important topic to understand the rotational motion also. If you do not understand this part, then it will be very difficult for you. All right. So, if you do not have any question, now I have a question. What if I choose that origin instead of M1, if I choose the origin that
It sound like you pressurizing sir to take the quiz. I'm like offline like those guys. I'll give that to you.
what? Shayan, what is your point?
Science and math.
Yes, sir.
With whom you are talking? Alright, so my question is, if I choose the origin at the location of M2, will the center of mass will be changed?
So the center of mass will be the same, sir. I mean, from M2 it will be 3.3 meters, like 32 meters.
Yeah, that's good, very good. So although you will find out the different calculation, right? But the center of mass, it will remain same. Remember, unless you do not change the mass distribution or the location of the mass, the center of mass will be the remain same. Whatever the origin you choose, it doesn't affect. Whether I choose the origin at that point or that point, the center of mass will be exactly the same point over here. If you consider the origin over here, you will get this length, which is the same location point. If you choose the origin that point, you will find out that that length, which is exactly the physically the same point, although you are getting the different length from your origin. That's why center of mass of a system is not going to change unless you do not change the mass distribution. Will it be possible that center of mass of a system, look at this, I find out the center of mass of these 2 point mass actually inside that region, right? Is it possible the center of mass would be outside of this mass? Let's say I have a continuous mass distribution. The center of mass would be inside the object generally. But will it be possible the center of mass of this system would be outside the object?
Yes, sir, possible, sir.
It's possible, remember. We'll see that one.
So when the
Yeah.
when the center of mass is outside of the object, then accident occurs.
No.
Yes, sir.
No, it could be, yeah, there's a possibility, but that could be minimized. I'll show that one. Don't worry about that. Yeah, thank you. At least you get that idea. Fine. Let's talk about center of mass for, I give you this point mass distribution. Now I'm going to find out, let's say for 2-dimensional case center of mass. Right now I find out for the 1-dimensional case. I'll find out for the 2-dimensional case. Let's say I have a sheet of paper. I'm to find out the center of mass of this object. Now I'm going to find out that one actually. Remember, I will write down that equation, general equation actually, center of mass actually, I write down m1 x1 plus m2 x2 divided by m1 plus m2, right? And so on. I choose the 2 mass over here. Now, what I'm going to do, I want to write the same type of equation for this 2-dimensional case. This one actually 1-dimensional. If I want to write down the 2-dimensional case, and it's a continuous mass distribution. 2-dimensional case, if you say that, sir, if I write down the y-com, that's also 2-dimensional. But no, this is for the point mass distribution. 2-dimensional means you have to consider at the time you are dealing with right now the area. Instead of length, you are going to dealing with the area, because the sheet of paper, it has only one dimension in the case, right? It doesn't have any thickness. It has, but that thickness is negligible. That's why it's a two-dimensional thing we can say actually. So to find out that one, I will define a parameter over here that called actually linear mass density. Linear mass density, which is, I will define lambda mass per unit length. If you say this is one dimensional, that one I can write mass per unit area is a dA, or for the three dimensional I will define mass per unit volume. This is a definition I am defining, linear mass distribution. Why I am saying that? Let's say I have this sheet of paper. If of that sheet of paper, if I choose that small region, if that small region has a mass dm and its area is the dA, let's say if I take the ratio dm over dA, what it will give you, if you take the total mass divided by total area, total mass divided by total area, it should be the same for linear mass distribution or homogeneous mass distribution, right? It means that mass is equally distributed throughout the region. It's the same pattern over here. There is no discontinuous, which is mostly ideal situation actually, right? Mass homogeneous distribution. Sometimes we do not get actually 100% homogeneous distribution of the mass in the nature actually, but it should be look like actually homogeneous distribution of the mass. That's called actually that homogeneous distribution of the mass. That mass means mass should be equally distributed. You can think about for also a rod. Let's say, I have this rod. This is a homogeneous distribution. Let's consider I have this mass, total mass of this rod is m and the length is L, and if I take that total mass per unit length, that's the length, the ratio. Now if I take a smaller mass, smaller region, let's say this region has a mass dm and its length is dx, dx is simply that length, then if I also get dm over dx equal to the lambda ratio, then I can say this, the mass is homogeneously distributed throughout the rod. That's the definition of the homogeneous distribution of the mass. It's also same for the two-dimensional case, also for the three-dimensional case actually. We use that idea over here to find out that center of mass for two-dimensional case. What I'm going to write in the two-dimensional case, the lambda, it should be m1 divided by a1 total mass divided total a. Let's say I have actually that this figure, I take a smaller chunk mass, this is the mass m1 and the area is a1, and this is that m2 and area is a2, and then you can say the total area actually that sum of these areas actually.
Sir, why is it A? Isn't it supposed to be V? Because
it's the area, two-dimensional case. I am thinking of the sheet of paper. Can you find out the volume of a paper? Shan?
Sir, this formula can only work for uniform object. If the object is not uniform, it won't work, right?
No. If the object is non-uniform, that also it could be used, but there will be a parameter also. That's the different case. I'll show that one. Don't worry about that, because non-uniform distribution is not suitable for you actually. But in that case, it would be one more case. I'll show that one, but try to focus on that part. Then I'll give you that idea how we are going to find out for non-uniform distribution mass also. Exactly the same procedure. All right. So that's mean I can write in that case this xcom equation was m1. Look at this, from m1 I can write actually that lambda into a1, right, and same way you can write down m2 would be lambda into a2, because you are taking this would be also m2 divided by a2 and so on. This is a homogeneous distribution. If you take the smaller mass divided by smaller area for different case and if you take the total mass divided by total area, that ratio must be the equal. That's the definition of the uniform distribution of the mass. Then my xcom become that formula m1 x1 plus m2 x2 divided by m1 plus m2, right? Then I can write this xcom is going to be, instead of m1 I'm going to write down the lambda into a1 x1 plus lambda into a2 x2 divided by, it should be again m1 plus m2, you can write lambda into a1 plus lambda into a2. Now you can factor out that lambda from numerator and the denominator, then you will find out a1 x1 plus a2 x2 divided by a1 plus a2, right? Then I can write down this one simply in a notation form. It's a 1 over a summation of I1 to n ai xi is exactly look like the previous case where I dealing with that point mass location, and right now I am dealing with that two-dimensional case, the area of that first object and the location. The same way you can write down the ycom, it should be 1 over a I1 to n, it should be ai yi, right? This will be the center of mass for two-dimensional case. If the system has an area, we need to deal with that part actually. And if you in term of volume, you can write down also same in term of volume. In term of volume, if you know that volume, then you can find out the same way. Xcom should be.
What did you write, sir? In term.
In term,
oh.
yeah. In term of
Okay.
volume. 1 over V summation I1 to n is a Vi into Ri. So Ri means Xi actually. You can write in that ycom, because it has 3 dimension, V I1 to n Vi yi and the zcom in that case actually 1 over V I1 to n Vi zi.
Sir, after you're done with this, can you show me the original formula?
Yeah.
The original formula.
Yeah, I'll show that. I think you're talking with someone.
No, I'm not.
Yeah, you are talking. We
I'm
heard.
talking to you, sir.
No, I asked you. Probably you are talking with someone else. All right, let's think about. Why use a different color? All right, let's think about, this is my 2 chunk of paper at this way. They give us the dimension. This is that 0.8 meter of this bigger one. Let's say this is actually that M1, and this is actually 0.4 meter, and this smaller one, let's say this is actually that M2, its dimension is 0.2 and also the 0.2, and I am to find out the center of mass of this object. Alright, I need to find out that center of mass. It's a two-dimensional case. I need to find out actually the x com and the y com. Then we will find out total coordinate of this system actually. Alright, so to find out that x com and the y com, the formula x com was basically it should be 1 over a summation of I 1 to n. It was ai and xi, which means I can write on this one, it should be a1 x1 plus a2 x2 divided by total area a1 plus a2, right? Same way you can write down the y com. So y com should be a1 y1 plus a2 y2 divided by a1 plus a2. I need to find out y1 y2 sorry a1 a2 y1 y2 and x1 x2. Let's find out the a1 first. a1 actually I am considering this bigger chunk of paper, which is the m1 I write down. So area would be 0.8 into 0.4, right, which means it should be 0.32 meter square. Am I right? And a2 would be 0.2 into 0.2, that's going to be that 0.04 meter square. This is a two-dimensional case. Now the total A should be sum of these, which is a1 plus a2, that's going to be actually 0.36 meter square. I find out this part. Alright, so this is my a1. I need to use this part actually. This is my a2 and this is my a total A. Now I need to find out that x1 and x2 and y1 and also the y2. Remember, x1 and y1 basically center of mass of this bigger object. Where it would be center of mass? Ideally, we are ideally assuming what should be that center of mass of this object. Generally, center of mass of this object would be at the midpoint of this object, right? And the midpoint of this object also, separately, if you think about the separately, right? Then x1 actually location or coordinate of this point, and y1 is also coordinate of this point, and x2 and y2 is also the coordinate of these 2 points. Now I have to find out this x1 y1 and x2 y2. So x1 should be it should be that distance, which is actually, you can see that figure from here to here distance, x1 is from here to here, which is half of that 0.4, and y1 should be this one, which is with the half of this 0.4, which will be the 0.2. That's mean I can write this x1 actually 0.4 and y1 actually that 0.2, and x2 would be 0.7 and y1 would be 0.5. You understand this one?
So how come it became 0.7?
Yeah, I'm expecting that question actually. Look at this. I am considering, I am referring the location of that point from this origin. From this origin, that makes sense. This one would be 0.4, half of this x1, and this one would be 0.2, half of this 0.4. I can reach that destination, which means the coordinate of this point actually 0.4 and 0.2, right? That's one right. The x1 actually 0.4 and y1 actually 0.2. Now for this one, I know the coordinate for this one should be 0.1 and also the 0.1, right? From where? From this one corner. Because this total length actually 0.2, half of this would be 0.1, and this total length is also the 0.2, half of this would be 0.1, which means that is the coordinate you are measuring from there. But I need to refer from this part. This total length actually 0.8, if you subtract this 0.1, then from here to here, this total length would be how much?
0.7.
0.7. This length actually 0.4 and this length actually 0.1, then that would be what is the total length? Is a 0.5. Do you understand, Shine, right now? Hello? Shine, did you get that one? Shine is gone. Alright, so let's drop that part. So fine. Now if I plug in that part actually over here, then you can find out this xcom. Xcom should be a1 is the 0.32 into that x1 is the 0.4 plus a2 is the 0.04 into that x2 is the 0.7 divided by total area, which is 0.36, and that will give you actually it should be 0.433, and the ycom should be 0.32 into y1 is the 0.2 plus 0.04, which is the a2 into y2 actually 0.5 divided by actually that 0.36, that's become actually 0.32. That's the center of mass of this two-dimensional case, and it is over here close to the bigger mass, right? Because that point actually 0.4 and the 0.2, I find out 0.43 probably over here. Let's consider this is my center of mass of this combined two object, which is actually 0.33 and 0.233. That makes sense, right? We said that the center of mass will be always closest to the bigger mass. That's why center of mass, these two sheet of paper will be closer to the bigger object, which is this one. All right. All right, let's
Sir,
talk
could
about.
it be outside the both of the paper?
No, it is inside the paper. Why it will be outside the paper?
No, sir. Can it happen, sir?
Yeah, sometime it could be happen depending on the situation. I'll give you an example right now. Can I get 10 or 15 minutes extra right now?
Sir, can you please explain why x2 is 0.7 meter? I didn't get that point.
0.7 meter is x, right? Okay, I'm going to draw it again for you. This is the case. Look at this. I know that center of mass of this object actually at the midpoint, this one my 0.8 and this one my 0.4, and the mid of this would be basically 0.4 and 0.2, right? Did you get that one?
Yes, sir.
Which is actually I'm measuring from my origin over here. Now for this one, it is actually 0.2 and 0.2, then its center of mass actually 0.1 and 0.1, but that one actually I'm measuring from that point. That is my corner, one corner of this shape, right? But I need to actually that measure the center of mass from this one origin, one location of that system. Then You say that this is actually 0.1. Am I right?
Yes, sir.
Then this total, I'm looking actually that distance, this one. I know that this total distance actually, how much? 0.8.
Yes, sir.
From this 0.8, if I subtract that one, I'll find out this distance, which is actually the 0.7.
Yes, sir. Got it.
Yeah, the same thing over here. This is actually your 0.4, and you have to add this 0.1 also to get this total distance from your origin. That's why it's a 0.5.
Okay, sir. Thank you.
Yeah, it's my pleasure. All right, can I get 10 minutes extra? Shan, where are you?
Yes, sir.
Where are you?
I'm here.
Sometime you are going to vanish. Can I get 10
No,
minutes
no.
extra? Shan?
Sir, we have to pray.
Yeah, I know that. That's why I'm asking you.
Uh,
Sir, will you take any attendance?
That's I am wondering actually.
Sir, makeup class of the attendance. One.
Makeup class. What do you think? Should I take the attendance or not?
No,
Now,
no, no.
Then I need to
No,
give.
sir.
Then I need to give the
No,
10
sir.
minutes extra. Otherwise, I'll take the attendance.
yes,
Okay,
please.
okay,
স্যার
okay.
একটা জিনিস না স্যার
No
আপনার সাথে
problem.
কথা বলা দরকার ছিল স্যার
Yeah,
sir, take the attendance.
No,
Shan.
sir.
হ্যালো
Yes.
আর ওয়াক্ত তো আছে নামাজের, আরো 20 মিনিট পরে পড়া যাবে।
No, no, no. Don't.
স্যার একটা কাজ, মানে আপনি তো মানে রেকর্ড দিতেছেনই, তো যাদের যাওয়ার তারা স্যার চলে যাক, প্যারাতে
জি,
নাই।
স্যার।
পরে just তো দেখে নিলাম।
Yeah, but remember this topic is very important. If you want to go leave, I don't have
I
any.
understand, sir.
Yeah, I don't have any objection. But
Sir, you can take extra classes after after vacation too. We don't have a problem with that.
yeah, so
We are
right
willing
now,
to do
all
extra
right. So can you give me only the 10 minutes? Within that 10 minutes, I can finish two
Yes,
topics.
sir.
Actually.
I think that
Yes,
you
sir,
can
you can
start,
take
Okay,
sir.
it.
okay, okay. No
Then,
problem.
sir, the topic will complete.
Only the 10 minutes.
Yes,
You
Shan?
can take 100 minutes, no problem. But do not take attendance.
Shan, will it be a problem for you if I take 10 minutes right now? Shan,
Sir, yes, sir.
will it be a problem if I take 10 minutes? Is your mocks is too far away from your home?
No, sir,
But yeah, it should be issue.
but it would have been helpful, Arki.
It wouldn't
No, no,
be there.
if
Then do
if you
one
would
thing.
have taken
Yeah,
attendance.
so then do one thing actually. If you want to go to
Sir.
the mock test, I cannot give you the barrier. You can leave, but by your responsibility, please go through these two topics actually. I'll just do two more topics right now.
Okay, sir. Okay.
Okay.
স্যার 5 মিনিট হয়ে গেছে স্যার।
Yes, sir.
That's actually the relative. Once I start the topic, then I will count down that 10 minutes from that.
Yes, sir. You can start, sir. Now, sir.
All right, let's talk about that to find out the center of mass for uniform mass distribution. Uniform mass distribution. Uniform mass distribution means any shape of object. Let's say a rod, uniform distribution of the mass, a box, a solid sphere, anything uniform distribution mass of that part. Actually, we are going to find out that one. Let's consider.
স্যার এর আগে সকল বিষয় তো নন ইউনিফর্ম ম্যাথ ডিস্ট্রিবিউশনে ছিল।
Yes, that was point mass distribution, not continuous mass distribution actually. Point mass. One mass is over here, one mass is over here, one mass is over here. That's not the continuous mass distribution. Right now, we are considering the continuous mass distribution. Discrete mass distribution, that was. Although by nature nothing is actually that continuous, all are discrete actually. But we can see this is, let's say, if you have a rod, you are seeing that this is a continuous distribution of the mass, right? That means there is no distance between the two masses, 2-point masses inside that rod. That's why we say that it's a continuous. The point is actually the continuous, one upon another, one upon another.
স্যার তাহলে পিস অফ পেপারেও তো স্যার ম্যাথ তো কন্টিনিউয়াস না।
Yeah, obviously continuous. But what if I zoom in it is? Will you find out it is a continuous function or discontinuous function? Everything actually is discontinuous function. Everything actually the discontinuous function. All right, so fine. So let's otherwise let's say I have this rod which is that m, its length is L. I'm going to find out the center of mass of this rod. Let's consider what I'm going to do actually. I'm going to use that formula. Remember, it's a continuous mass distribution. That what I'm going to do, idea is, let's say I choose a small mass over here, which has a mass actually that dm, and its length is also that dx. If I can find out the center of mass of this one, then by that analogy I can take one more smaller mass from there, one more smaller mass up there, and so on, right? I can find out small segment of that. Instead of finding the smaller segment, what if I integrate this total system from 0 to L? That will also give me that center of mass of this distribution, right? What you did actually, when you write that summation of something, some one xi, let's say x1 to n, which you add actually x1 plus x2 plus x3 and so on, right? Summation mean is that, right? So integration is also the one kind of summation, because if you extend this leg of this integration from both to side, you stress it, then you will find out this integration. This is the same thing. Integration is nothing except the summation of that one. Over a range actually we do that one by limiting value. Same thing we are going to do. Instead of adding this smaller segment over here, if I integrate from 0 to L of this length, I'll get the same thing. Summation actually, I am adding all the segments, smaller point mass to find out the center of mass. Instead of that, if I simply consider a function and apply that function onto that object, and if I integrate from 0 to L, that will also give me the same one. That's the purpose of doing integration of that system or anything or any function. All right, so then I can write that x com for this one, I'll simply write down 1 over m integration. Remember that function when I'm writing xi into mi, right? 1 over m in the integration format, we write down the x com 1 over m, right? I'm integrating this one. Now that would be basically for x into dm. And that's limiting value. I need to give something over here. Let's say this is xi dmi. Let's say I want to some value. It should be, I don't know actually that integration is a general form. I want to n, you can write down, or simply that's the formula actually, a general formula we write in that form. Fine.
Sir, should it be 0 to L?
Yeah, for this L it should be, length should be, but this is the general formula I'm writing. Sometime you will find out also that r com 1 over m, it should be 0 to infinity ri dmi. This is one more formula to find out that center of mass for this case. But general formula. Now if we want to find out for this rod, specific rod, I'll write down x com, it should be 1 over m, integration would be 0 to L into smaller mass, which is actually that dm into that x. What I'm doing by this one, basically, oh god, I have this rod, homogeneous distribution of the mass. It has this mass and this is the length, and what I did, I choose this smaller segment of this one, has a mass actually the dm and its length is dx, and this mass actually at a point, I choose the origin in one side of this rod. Actually, let's say I choose, this is my x-axis and this is my y-axis, this is x-axis, this is y-axis. The location of this point mass from my origin actually at a distance x. You understand this one, this format? This is simply the aim, this is simply the location of that aim actually. I write down exactly the same way, previous case. In that case, it was actually 1 over m summation of I1 to n, it was mi into xi, integration sign I replaced by the summation, and mi actually the dm and x actually the x, the location of that mass. Do you understand this one? Is there any question over here? That's the application of the integration. Try to understand.
স্যার এইটার এই আগেরটার মধ্যে ডিফারেন্সটা কি স্যার?
Which one? The previous one?
স্যার একটা লিমিট দিলেন i equal to 1 আর n, আর এটা আবার দিলেন l আর 0 কেন?
Yeah, this is the general formula. I do not know whether I would be 1 to 0 or 0 to n. I do not know this limiting value. It's a general formula, but this one I write down customized for my this object, because if I, instead of rod, if I use the, let's say, solid sphere, then even though this limiting value is also going to change. Let's say if I choose my origin instead of there, if I choose the origin is over here, this is my origin, then what should be the limiting value? Let's say from origin that value to this, the location actually that a, then how this limiting value is going to change?
স্যার a plus x হবে।
A plus x, yeah, it should be a plus x to lower limit, right? And the upper limit would be what?
a plus l.
A plus l. Do you understand right now?
Yes sir.
Yeah, that's the application of integration. That's the purpose to doing the integration or the math. Math is very beautiful.
আর স্যার ইনফিনিটির পার্টটা?
Which one?
স্যার আরটা, r com.
R com is a general form actually. This is one more general form equation there. It's the same thing. I write on the x com instead of x com. If it is the 3-dimensional, you can write on the R com. X is only one dimension. R has in term of x, y and z. In that case, it would be actually that triple integration. If you separate separately. Yeah, so are you familiar with the triple integration?
না স্যার, mind rotation স্যার।
You will do that into your higher, probably in the math 120, they will introduce that idea actually, the triple integration. That's called actually the volume integration. Double integration is the area. Is any of you have done this math 120 over here? Wow, fine, no one to
Up.
It's done? What is up? 10 minutes?
No. Notes.
All right.
সায়ন্তর মাইক খোলা আবার।
আমি জানি, আমি তো নোটস দেখতে যাচ্ছি।
Wait, you should leave. All right, so this is the formula. Now the problem is, can anyone tell me, can I integrate this one?
It will only be m.
Can I integrate this one?
Yes, sir.
How?
It will only be M. Like,
Only m? What about the x?
The XM.
xm? Can anyone tell me whether I can integrate this one or not? Arisha, can you tell this one? Or Nawaz? Or Abdullah? Can I integrate this one?
So dm is a constant value, sir. So
dm is a constant value.
Uh,
Did you do the integration in your higher secondary level or A level?
No, sir.
Huh?
তার কোর্সে কিন্তু ভুলে গেছে
Who said no?
For me, I have skipped in
Uh,
HEC 23.
Come on, guys. Then do the course again. Without integration, you cannot be engineer.
Actually, I have learned it, but I forgot it.
Everything is happening. Yeah, that's the problem.
স্যার দুইবার করছি বাট 10.7 পর্যন্ত স্যার ভুলে যায়
Right now you need to do that math again. Remember, if you can remember when you writing integrate, you write down the x into dx, right? Or
Yes, sir.
you did y into dy, or you write z into dz. As a function as is function of z, function will be as a z. You write sine x into dx, but if you write down the sine z, then you cannot integrate this one. Then you, someone giving the noise, please mute yourself, because it has to be same parameter. Look at this, x with x, y with y, or z with z. This is the two different parameter. This is the m and this is the length. Is it the same identity or same parameter?
No, sir.
No.
One is mass, one is the length or the position of that mass, which is length actually, or the displacement. So I cannot integrate this one right now because it has to be same parameter. Otherwise you cannot integrate actually. Then what I can do, I have one more clue actually. They give you the homogeneous distribution of the mass. If I take dm over dx or total m divided by total length, then this ratio must be the same, which means that if I take this small chunk of mass divided by length of this mass, whatever the ratio I will get, if I take the total mass divided by total length, it should be the same distribution. That's the definition of the homogeneous distribution of the mass. All right. Then from here I can write down, it should be dm should be lambda into dx. Can I write?
Yes, sir.
Yeah, that's called the variable separation. Instead of dm, you can write down the lambda into dx into the dx. Now lambda is constant over here, it's fixed. In the previous equation, someone tell me, yeah, what if I can take the dm is constant? No, dm is not constant. Even the x is not also the constant into this function, because m is changing from starting from that point, whatever the m over here, if you take that region from here to here, is the m is same? M is gradually increase. If you start from the origin, if you goes in that direction, m is gradually going to be increased. X is also changing, which means both two parameter over here into this equation is a variable, it's not constant. You cannot consider dm is constant or x is constant for this function, right? According to this object. Now I can take that integration of this one. It should be, oh god, it's running m by, because lambda is constant, 0 to l dx, x into dx. What's wrong? Hello, can you hear me?
Yes, sir.
Yes.
Oh, that's disturbing my notepad. Oh, end of the moment, it's disturbing. Please give me one moment.
লোড বেশি পড়ে গেছে স্যার।
Probably.
স্যার নোটপ্যাডেরও মাইন্ড রোটেশনাল স্যার।
Yeah, that's a device. I don't care about that. Now I can integrate this one, x into dx, right? What should be the integration if I take that x dx?
x square by 2.
X square by 2.
X square by 2
is going to be x square by 2, 0 to L. Then this x should be 1 over m. Lambda, I can write on m over L into, this is going to be that L square by 2 minus 0, right? Then this m will be cancelled out. I'll find out this x is going to be that simply L by 2, because 1L will be cancelled out from there, right? Then we'll find out that center of mass of this homogeneous rod is going to be at the midpoint of this rod, which is actually the L by 2. Did you get my point? How we're going to find out the center of mass of this homogeneous distribution of the mass? And what if someone asks me, if it is non-homogeneous distribution case would be look like, the procedure is exactly the same. In that case, you will find a parameter, let's say this lambda would be something constant factor over here. Let's say, if I say it should be some constant factor k into dm over dx. This constant k has some relation. Relation means, let's say if you start from this center into that direction, with respect to the distance, actually the mass is more over here with respect to that. It should be k inverse. For this one, this lambda should be k inverse dm over dx.
Dear sir,
Yes, Shine, do not talk right now. If you want to go, you can go. All right? There will be some constant factor actually in terms of non-homogeneous distribution. How the mass actually the distributed. This one telling me mass is more distributed from your length actually. Inversely proportional of the length actually. There will be some condition actually. Those are actually not suitable for you in this level, in introductory level. We are not discuss about this non-homogeneous distribution of the mass, but it could be done, remember. That's why I'm going to, I don't want to dishearten you that I show a technique, but that's not going to be that actually applicable for all the system. It will be, because always I try to show you the general procedure. There must be some way you can apply this method also for non-homogeneous distribution of the mass. All right, this 10 minutes is over.
Sir, 20 minutes over, sir.
All right, thank you very much. I have one more problem actually. I will discuss or I will make a note, then I will post it actually into your Slack, because time is up. You should guys go to the mocks. Thank you very much, and have a nice Eid vacation. We are not going to meet before the Eid. We'll meet after the vacation, right? All of you have a very good